Good day, everybody. Today we're going to look at solving a math problem that made the news somewhat. First noticed it from this little blog. Apparently I'm not a math genius in it. And it references this article from the UK asking if you need to be a math genius to send a parcel. It's a little dated here. Main thing is you have to figure out like the length and the girth of the package, and then they found that the maximum volume of the package. So let me see if I can find that real quick here. So here's where the problem sort of begins. It's maximum volume 225 centimeters. That's bad notation there. That's actually you take the longest side and you add it to double the two smaller sides. So essentially it's length plus the girth around. If you add those numbers, that's the maximum allowable, but that's not the maximum volume, that's a length. And then down here, this lady, I believe, declared the maximum volume allowed is 82.68 liters. Yeah, here's the volumetric area, not a good term. You have the two shortest dimensions, multiply them by 2, so that's length around. Add the length, needs to be under 225. Here's a recent link, but they have since increased it. But so now the length plus the girth, I like to say, can be up to 245. Also, they don't want anything longer than 120 centimeters. And that's where the problem comes in. So again, this guy worked out the volume using Calc 1, but made a reasonable assumption, well, I guess he claimed to prove it, that the two smaller sides will be equal when you have your maximum volume. I'm going to do it without making that assumption. And then we'll both get the same result, namely, well, he converted to meters, but so 105 liters. So way more than the 82.68. It turns out, again, the 82.68 is if the longest side is 120, then the two smaller sides, I believe, are roughly 26.5 centimeters each. And then you get this volume if you put it in liters. But that's not the dimensions for maximum volume. So without assuming the two smaller sides will be equal, even though that's a reasonable assumption, again, what we want to do is want to maximize the volume. I'll have Z be the longest side and X and Y the two smaller sides. And then subject to the length around, 2x plus 2y plus the length has to be smaller than 225 centimeters. Yeah, I put hand in first octant. I should lower it. I mean, that's a tighter constraint. That's on a plane in the first octant. So it's a bounded constraint with X and Y and Z all positive. But anyway, so I did two ways. One with Lagrange multipliers, this first way without. So if you solve for Z and sub it into the volume equation, then we have this function of two variables. And well, we'll get the critical points. So if I get the critical points, f sub x, f sub y equals 0, gradient 0. Oh, and before I do that, so if at this point I also assume x and y are equal, then it becomes a one variable Calc 1 problem, which is where he got at some point. If we accept that a equals b, we got that 225. I have x squared minus 4x cubed. Find those critical points. But if I don't want to assume that and have it just come out naturally, there's the critical points. Well, to find the critical points, f sub x equals 0, so the x partial, 225y minus 4xy minus 2y squared, and then the f sub y partial, we want that to equal 0. Get that equation. You can factor y from the first and x from the second, and you get a bunch of zeros. They will all lead to the volume being 0, so they're not going to give the maximum. the non-zero critical point will occur when what's in parentheses both are 0. So if I put what's in parentheses equal to 0, I get these two equations. And solving these, show a little bit of the work here. Multiply the bottom by -2, and then add, and then divide by 6. This is multiple of 3. It's 75 times 3, so divide by 6 gives me that. And I didn't do the work, but x, of course, will be the same. And then z can be found by plugging back into the original thing here, right? So we had to have this constraint. Obviously, having equality will be needed for maximum. So if I plugged in my x and y into that, I get z is 25, and then this will be the maximum volume. And well, if you want to show it's a maximum, well, I mean, I did the discriminant test, and so it's a local max there, but we're on a closed bounded region, so I'd have to check the boundary here of this triangle, and it's going to be 0 on these edges, and then here, it's not really, it's pretty obvious. It won't lead to a bigger value, but on this line, the critical value, well, again, occurred at y equals x, which was 225 over 4 for both, and then z ended up being 0. For the second method, if I use Lagrange multipliers, I've got a function subject to a constraint, so I want f sub x to be lambda g sub x, f sub y lambda g sub y, f sub z lambda g sub z. So these are easy enough to differentiate. yz lambda times 2, xz lambda times 2, and xy lambda times 1 for those. And a little trick here from symmetry: if I multiply this top one by x, and then this next one by y, and this last one by z, at xyz, and then if I add these up, I'll get 3xyz lambda times this sum, but this sum is 225, so I can solve for lambda. If I divide by 225, which is 75 times 3, I get lambda's xyz over 75, and now I'm going to put this lambda in to these three equations right here. So for the first, yz equals, there's the lambda times 2, and again I'm canceling y and z, so they could be 0 for a solution, but that would lead to a minimum volume of 0, so this won't write that down. Otherwise we get 2x over 75 equals 1, or x equals 75 over 2. And similarly over here, if I put in for lambda xyz over 75, well, that's pretty symmetric. The x's and z's cancel, and I'm left with 2y over 75, or y is 75 over 2. And then lastly, for this one, if I plugged in xyz over 75 for lambda, xy's cancel, and so I just get z equals 75. So same critical value. Now here we're on a constraint, so you just sub in any of the critical values. We had some at 0, which would lead to v equals 0, but this one with a positive x, y, and z has, of course, positive volume, and that'll be the max. So that's the solution. Again, I'll link to these if you want to see the blog and the confusion. All right. So hope you enjoyed that. Thank you, and have a good rest of your day.